You are welcome to the physics class again. Whenever it is time for physics, people become happy. Become happy for why? Why are you happy whenever it is time for physics? Because it is all about technology. It's about what we use every day, digital world, technology that is moving the world. So you have not made any mistake by becoming glad when you heard physics. Relax now. So we start. Today, we are going to have a look at the efficiency of machine. In our previous class, we were able to understand the meaning of the velocity ratio. Velocity ratio, I told you, simply means the distance moved by the effort to the distance moved by the load. So, and I told you that it just simply depends on the geometry, how the machine is constructed. And because of this now, it is not affected by the friction. Friction does not affect the velocity ratio of a machine. That is why I was able to bring in mechanical advantage in our previous class for you to understand that mechanical advantage is affected by friction. Friction is that force that opposes the movement of two objects in contact, two surfaces in contact. Okay, now the machine is not always effective or efficient as expected because of this friction. But there was something I told you about in our previous class, an ideal machine. I said an ideal machine is a machine that is not affected by friction. And on such a machine, the work done by the machine is equals to the work done on that machine. That is, the work output of the machine is equal to the work input in that machine. And from there, we're able to drive a formula whereby the mechanical advantage equals velocity ratio. That's where I stopped. So today, we'll look at what we call the efficiency of a machine. The efficiency of a machine is always expressed in percentage, in percent. As is to check how efficient that machine is. That is given by the efficiency of machine E is given by the work output over work input multiplied by 100%. I told you that we express efficiency of a machine in percentage. That's why we multiply by 100. And in our last class, I told you the meaning of work output. What is work output? The work output is equals to the load. That load that you move, that is moved, the load multiplied by the distance moved by the load. That is what we call the work output. That is the work the machine has done. Then the work input now is the work the person supplied on the machine. What is that work input? Work input now, the work input is equals to the effort multiplied by the distance moved by the effort. Okay. In that case, it means that efficiency of a machine now, efficiency of a machine is equals to load work output, which is load times by distance moved by the load, over effort times distance moved by the effort times by 100 over 1. In our last class, I said that load over effort is what? Mechanical advantage. So efficiency of the machine is equals to mechanical advantage. Mechanical advantage. What is distance moved by load and distance moved by the effort? So distance moved by the load, distance moved by effort is the inverse of the velocity ratio, because velocity ratio is distance moved by effort over distance moved by the load. So, but here we can see that what we're getting here now is distance moved by the load. Let me say, okay, multiply by 1 over velocity ratio. Because distance moved by load over distance moved by effort is the inverse of distance moved by the effort per distance moved by the load. Now, multiply by 100 over 1. So we can see that efficiency of a machine now is equals to MA over VR times 100 over 1. That's what we call the efficiency of a machine. We are going to understand more of this when we enter into calculations. With calculations, all those formulas will be easy to understand. But the basic thing is to understand what is going on. What is going on here is that we have to know how effective, how efficient the machine we are using is. How can we do that? We can do that when we know the work output, the work that machine can deliver, and then the work that the person is using is to deliver on the machine. They are very important. So when we calculate the work done by the machine per the work done on the machine times percentage over 1, we are calculating the efficiency of the machine. How can we do that? What is the work output? The work output simply means the load itself multiplied by the distance moved by the, that is the work done. The load itself, which is the force here now, multiplied by the distance moved by that particular load. Then what is the work input? The effort multiplied by the distance moved by the effort. So when we now combine this and this together, we have that efficiency of the machine is now load of effort times by distance moved by the load per distance moved by effort. But in the previous class, I told you that velocity ratio is distance moved by the effort per distance moved by the load. But what I'm getting here now is distance moved by load per distance moved by F, which is now the inverse of the velocity ratio. So here we can now have efficiency is now equals to mechanical advantage times by the inverse of the velocity ratio times 100%. So we have a formula here now. Efficiency is equals to mechanical advantage per velocity ratio times 100/1. In the next class, we're going to apply the formulas so as to understand the physics more. Thank you very much.